Okay guys, if you look at this problem here, so we want to determine whether this series is convergent or divergent, right? If you look at this alternative series, right? So first one here, so I did a video on for this one here. So here 1 times sine of 1 over minus that term plus 2 times sine of 1 over sine of 1 half. So this is the general term here, right? General consecutive terms. This is the odd term and this is the even term. So odd term is n times sine of 1 over n, and even term is negative n times sine of 1 over n. So we showed that this one, because this subsequence converges to 1, because of that the limit of this sequence does not converge to 0, therefore the series is divergent. So let's look at this problem here, right? So this is the general term. This is odd term and even term. Odd term is n times sine of 1 over n squared, and even terms is the negative of that, right? So let's consider this term here. Y sub 2 and anything sub 2 and minus 1 is, so I rearrange that sine of 1 over n squared divided by 1 over n, right? So right here I add n and I divide by that quantity because I did nothing, and sine of 1 over n squared divided by 1 over n. So I take this n to the denominator, then this becomes 1 over n times sine of 1 over n squared divided by 1 over n squared. So as n tends to infinity, we know that this term approaches 1, but this term approaches 0 as n tends to 0. Then whole this, then this yn, so this term approaches 1, this term approaches 0 as n tends to infinity, right? 0 times 1, 0. So y sub 2 n minus 1 approaches 0 as n tends to infinity. So the quantity, so look at this, the quantity, this is the quantity of that alternative series. So the first term, second term is the negative of that, and third term is this, and fourth term is the negative of third term, like that, right? The quantity of this one is reducing to 0. Now we have to show if so we know the alternative series test. Now we have to show this one is, so this yn is decreasing, so monotonically decreasing. So this is our, so this term is y sub 1, y sub 2, y sub 3, like that, y sub 4, y sub 5, right? So now we have to show yn is monotonically decreasing. So we know that y1 and y2 are yeah. So right, decreasing. Now here, wait a second. So this is y1, yn. If you ignore these signs, right? So we just consider the quantity, right? So not this one, yeah, we just consider the quantity. So bn, so this is this quantity is b sub 1, which is same with yn, b sub 1. I take this quantity, I remove this sign, the quantity is same with b sub 2, b sub 1. So b sub 1 and b sub 2, b sub 2 is the same. The quantity of the third term is b sub 3 and the quantity of fourth term is b sub 4. Here we know that b sub 3, the quantity of b sub 3 and b sub 4 are the same, right? These quantities are the same, but we have to show this sequence is monotonically decreasing. So let's show that, right? So basically here we have n sine of 1 sub n squared, right? I take this is f of n. So I want to show this one is monotonically decreasing. We know this one is positive and this one is, this sine function is decreasing as n increases, right? Because sine of 1, so sine of 1 here, this is sine of 1, and as n increases, the sine function decreases to 0, right? The sine curve kisses with x-axis as n tends to infinity, right? I mean, this sine function decreases, but we have to show this product of n and sine of this is decreasing. So let's differentiate this function. Let's differentiate this function with respect to n. So if the derivative, if f prime of n is negative, we can say this function is decreasing. So let's show that, right? F prime of n is equal to sine of 1 over n squared minus plus n. I differentiate other term, sine term. To differentiate sine term, we get cos 1 over n squared, and differentiation of this bit which is negative times n cube, negative 2 times n cube. Yeah, so let's rearrange this. Sine of 1 over n squared, negative, this is negative, 2 over n squared cos 1 over n squared, right? So here sine, right? Sine of 1, and sine function is something like this, and cos function is something like this. You can show that this is negative, right? If you look at the graph,